So suppose we have to prove an equality like A equal B, or an identity A identity B. So we will have something of this form. So now we will show three different techniques. The first one can be called proof by deduction, or if you want a proof that goes from the left-hand side to the right-hand side. Typically, it's applied for algebraic proof, so it means equations or identities that contains algebraic expressions, so it means expressions in some variables, x, m, or whatever you have, okay? So you will have something that it will look like A equal or identity B, let's say equal to B, and we will have to go from the left-hand side to the right-hand side. Again, rule number one, you don't move stuff from the right-hand side to the left-hand side. What you need to start with is what you have in the left-hand side. So for example, let's prove the identity that A plus B all to the power of 3. It is an identity and it's equal to A to the power of 3 plus 3A squared B plus 3AB squared plus B cubed. Now these, you might say, okay, but this I know it from the binomial theorem, and that's actually a way to prove it. So we take the left-hand side, right? And we know that using the binomial theorem, one can exactly prove that this is the expression that it's on the left-hand side. But I could also just multiply out a factor of A plus B and A plus B squared, and then, for instance, multiply out A plus B times A squared plus 2AB plus B squared. And you know very well where I'm going, because now I'm going to have A cubed plus 2A squared B plus AB squared plus BA squared plus 2AB squared plus B cubed. And then I will have to sum them up, right? So I will have A cubed here, I will have an A squared B here, and an A squared B here, and an AB squared there, and an AB squared there. So I'm going to clearly have 3A squared B plus 3AB squared plus B cubed. And then I arrive to the right-hand side, so I can just write LHS identity right-hand side, or I can write QED, okay? So I proved something like that. Sometimes it's more convenient, though, to go from the right-hand side to the left-hand side. It's still called proof by deduction, and that's the same, okay? So we could, in the same way, redo the example that you saw in the first video. So, for example, let's say that we want to prove this identity, right? So 1 over m plus 1 plus 1 over m squared plus m identity, 1 over m. And therefore, also in this case, right, we know very well that we did it before. This is also taking the left-hand side here, rewriting it, and then finding a common denominator, which is m plus 1. Here I'm going to have m plus 1, and then this is a factor that it's cancelled out with the factor in the denominator, and therefore I'm going to have 1 over m. So this is the example that we saw in the first video, and it's an example of a left-hand side to right-hand side proof. I want to propose you another example that it's the first exercise in the booklet. So it says, by using a left-hand side to right-hand side prove the following identities. And the first one, it's actually something that looks like this. So it's x minus 1 all squared, identity x squared minus 2x plus 1. And I would say here, it's clear, right? I take the left-hand side, so I take x minus 1 square, and I expand. So I will have x squared, the double product, minus 2x plus 1. And that's it. So this is it, okay? If they ask me to verify the result for a certain x, what I'm going to do is that I'm going to say left-hand side. For example, in the third task, they asked me to verify the result for x equal 2. So I'm going to take the left-hand side, substitute 2, so I will have 2 minus 1 squared, so 1, and then I will have the right-hand side, which is just 2 squared, which is just 4, minus 2 times 2, 4, plus 1, which also makes 1. So we will actually have 1 equal 1. And this is as well demonstrated.